Okay, we are now going to finish the solution of the problem, and then we'll get the answer at the end of the day. So this was the system, and from the previous video we applied Newton's laws, Newton's second law to the mass m1 and the mass m2. We took a free body diagram, derived the equations equation star and equation 2 star. From equation 2 star we derived a formula for the tension in terms of the accelerations, and previously in the first video we related the accelerations using a kinematic analysis. We now have all the information necessary to solve the problem. Okay, so the main thing that we're going to use is the tension is 4m times A1. This will give us an explicit expression to derive the equation for the mass m1. Okay, we're going to use the formula for tension is equal to 4ma, and we're going to put that into the equation for the mass m1. Let's do that. Using the free body diagram, we have the mass, which is just m, x1 double dot is equal to minus k x1 minus 2 into the tension, which is 4m a1. A1 is just the acceleration of the mass m1. So we just put that into the equation. So we'll have mass m1 x dot is equal to minus k x1 minus 8m x1 double dot. Put everything on the right sides. So what do we have? Take this, put it on the other side. By rearranging the equation, we have 9m x1 double dot is equal to minus k x1. Put everything on the same side so we have a homogeneous equation. 9m x1 double dot plus k x1 that is equal to 0. Now, if we compare this to an equation in the standard form, what is our standard equation? We have mass connected to a spring. Usually there is a damper, which we'll disregard in this particular problem. Standard equation is mx dot dot plus kx is equal to 0. So for a mass and a spring, disregarding the damper for the moment, that is the standard form, and we can then use the standard form to work out the equivalent spring constant. Compare the equations. We have something times a double derivative. We have mass something times a double derivative plus something else times just a deflection. So this is basically putting it into the standard form, dividing by the mass on both sides. That's the equation. That's the standard form. And if you look at your textbook, this is basically going to give you that. These are basically the same equation, like so. And what does that mean? This basically implies that the natural angular frequency is going to be the square root looking at these equations, putting that into the expression. And that is the result at the end of the day, which is what it was in the problem. This essentially solves the problem for the mass pulley spring system, and we get our answer. In the next video, I'll just make a few brief comments about some observations that you should note in solving this particular problem.